they're gonna need to lift your car go up, right? Because air exerted on a force exerts the force on a small piston. Okay, they use the air pump. Okay, the device that can compress anything by using the air. All right, and a small piston of a circular cross section having a radius of R1 5 centimeter, okay, which is quite small. All right, you have the piston right here. You have the whole car lift like that. Okay, this side contains a small piston, right? And this one contains a bigger piston in it's gonna move up, right? And this pressure is transmitted by an incompressible liquid. Okay, this term is quite important. Incompressible, which means that we can apply the Pascal law, which state that F1 by A1 equals F2 by A2. Okay, because the pressure are different. เดี๋ยวนะครับมีคนพิมพ์อะไรมาหรือเปล่าโอเคจานรับหน่อยครับโอ้ sorry ดีนะที่ผมใส่หูฟังโอเคโอเคครับปอนะปอนี่คือประภาวิทย์นะเท่าที่ผมจำได้ครับโอเคwho else wanna join the Zoom classroom just let me know, okay? Because it's in another monitor. I cannot see it. And let's move to that. Okay. You have this set up, right? In the pressure. Yeah, this word is quite important. Incompressible liquid. Okay, it means we can apply the Pascal law. Our second piston, which is the bigger one, this one has the radius R1 5 centimeter, right? 5 centimeter, and this one here has the radius of 15 centimeter. Wait, oh. Yes, 15 centimeter R2, right? R2 15 centimeter, and neglect the weight of the piston. Okay, assume that the piston here are very light. Okay, and the force must be the compressed air exert on the small piston. So what is the value of this force, right? And in order to lift a car weighing 13,300 Newton, and what air pressure would produce a force? Okay, that's the first question, right? In order to lift a car weighing 13,000, so it means 13 ton, okay, approximately. Okay, we have a holder like this, okay, and we lift a truck. I think this would be a truck actually, because it's 13 ton. Okay, usually one car would be only 1 ton, right? So this is a truck, okay, and this one is no, it's not kilogram, it's weight already, so it's around 1 car, single car. Okay, and the force here, the weight, right? The weight here, the weight is 13,300 Newton. All right, and what air pressure? Okay. So we need to know the compressing force right here. Okay, F1, right? I think. What is the value of F1? That's the first question here. Okay, F1. What is that? มีใครอีกไหมครับ ผมพยายามชำเลืองดูจอเรื่อยๆนะครับ ขออภัยด้วยนะครับ ปอนะครับ The second question, what air pressure will produce a force of that magnitude? Right. So, you know that this is the piston, right? And here is the liquid. Okay, you have the liquid inside. This is called incompressible liquid. Okay, incompressible liquid. This is the liquid. Okay, you fill it with the liquid, and you try to okay, this is the closed section. Okay, you close this one. Okay, and you drill it. Okay, you drill a hole here. You let the air get into this. Okay, you let the air get into this small hole, tiny hole, and you try to compress this piston by air. Okay, and of course there will be pressure caused by the air, and that pressure will take place in terms of force, right? Because once we multiply the pressure by the cross-sectional area, we get a force, and this force F1 will compress this liquid, and this one is gonna move up. It can lift this truck or this car up, right? That's the whole system, the whole mechanism. All right, I hope you would understand the configuration of this problem. It's quite complex, right? It's quite it's an extension to the typical problem for us. Okay, and let me observe what's going on with you in the YouTube channel, right? So that I can see who has typed something in the YouTube channel. Okay, the whole system is like that, and มีคนพิมพ์อะไรมาสักอย่าง เดี๋ยวดูที่ไลน์ก่อนนะครับnothing นัทพัฒน์เอธิโกสินครับอ๋อคุณดูที่อันนั้นใช่ไหมครับอ๋อโอเค yes okay no problem up to you okay yes นัทพัฒน์yeah we have let me monitor what's going on with you in some channel, because I need to capture your name right from the right Natapat. Okay, I can see you, and most people are in the Zoom to YouTube channel, right? 6 lecture right here, and right, okay, and I'm gonna reduce this page, right, so that I can see you. This one for most people in zoom to YouTube channel โอเคณัฐพัฒน์อยู่ที่อันที่มันถ่ายตรงหน้า iPad เลยนะครับโอเค alright so the problem is that I cannot see okay right now no problem and yes let's go ahead with this problem we need to calculate first the F1 let's try to completely understand what is going on the air pressure we put it a force of that magnitude okay the second question is P air okay P air what should it be and show that the work done by input and output piston is the same okay and the third the third scenario the third question is proof or verify right verify work input equal to work output okay out okay let's start with the first one F1 right F1 is the force on the left hand side on the small piston and of course we have this equation right the Pascal law is quite easy okay pressure at this location and this location are the same right we neglect the effect of height difference okay the when this one is higher than this one we neglect the pressure caused by the small amount of liquid above this level and yes what we want to know is F1 right from the Pascal law we have F1 by A1 equals F2 by A2 right so let's manipulate this equation you know that F1 is gonna be F2 A1 right divided by A2 all right in you may have to substitute everything right F2 what is that F2 is the weight of the car right we neglect the piston and the supporter mass here assume that they are very light and F2 is the 300 Newton all right that's the first quantity you need to know A1 what is that A1 because the piston has the cross-sectional area as a circle right so we would what happened ทำไมมันมาเป็นแบบนี้นะครับthis one all right and because this one has the circle so we need to use the area of circle right and pi pi r1 square right pi r1 square and you know that r1 is 5 centimeter right and and yes you have here pi 5 times 10 raised to negative 2 and square right and a2 is pi r2 square right and it's gonna be pi and 15 times 10 raised to negative 2 square right so we leave all these three quantities into this expression and yes f1 will appear as f2 which is 13300 and times pi a1 is 5 times 10 to negative 2 and square right and you have the denominator here 15 times 10 raised to negative 2 and square right yes, we still leave 13,300 like that. And yes, you know, pi and pi can cancel each other right easily right here. And yeah, inside this we have inside the square we have 5 and yeah, 15, right? And times 10 raised to negative 2 times 10 raised to negative 2 and square, right? 10 to the negative 2, and you know that we can easily again cancel the unit conversions term, right? And yeah, 5 and 15 is gonna be number 1 and number 3 easily. And we have finally 13,300 by 9, right? And yes, we you can go to any calculator, right? It's right here, I don't know. Yes, 13 133 oh 13300, right? And divided by 9, it's 1477, right? 14, it's approximately 147.77, right? And so on, right? With the number 7 infinitely. Okay, and the unit F of F is, of course, is Newton, right? We get the first question, the answer for the first question, right? In yeah, let me capture what you type here a little bit. Okay. Okay, เผาวินเนาะแล้วก็ until กันทพล right? And from กันทพล to อัครวัตร alright, and one person here ณัฐพัฒน์อิทธิโกศลนะครับ alright. Yes, so okay. The desktop, this one. อ้าวทำไมมีเท่านี้นะตะกี้ผมก็แคปเจอร์ไปเยอะนะปวินคนแรกมานี่นะครับ and from กันทพล toณัฐพัฒน์ alright.เดี๋ยวครับงงครับว่าทำไมแคปเจอร์แล้วไม่ไปไม่มาเฉยเลยครับ I don't understand คือคอมพิวเตอร์ผมรันงานวิจัยไปด้วยนะครับ CPU น่าจะนะครับโอเค no problem. Okay, the second question is right here, right? What is the average? Let's check whether our solution is correct or not. It's F1 is right there. It's yeah. It's 1,000, right? I'm sorry for that. ไม่มีใครท้วงผมเลยหารมันต้องเหลือพันสิ Okay, it's what is that? 1477. What is that? Here, right? 1477, right? And 7 infinitely. Yes, and yeah, that's correct. And the next one is we're gonna need the term P air, right? P air or P2 is given by the the force F1, right? Divided by the cross-sectional area of the piston on the left side here. Okay, this one. All right, and yeah, P air or pressure will be will of course be 1477.7 divided by pi r, which is 5 centimeter, right? And 10 to the negative 2 square, right? And let's see what is the result in decimal unit, right? 1477 like that. And let's see what's going on right here. This is the force F1 and divided by pi, right? Pi times 5e minus 2 and square, right? นึกไม่ออกว่าถูกใช้ Google เราเนี่ยครับง่ายๆนะครับโอเคไหมก็ so you get the result like that 59892.077 59892.077 blah blah blah, right? And let's check whether it's incorrect. My God, 1478, right? It's approximately less than 5. What is the reason why we have that? Moment สูตรลับประวีนด้วยคอมพิวเตอร์ช้านะครับไม่ใช่เจ๊งนะครับเนื่องจากว่าประมวลผลหลายอย่างครับตอนนี้ผมน่าจะต้องซื้อ Mac mini มาเพิ่มแล้วครับเพราะว่างานเยอะนะkind of okay and Sulaprovin there in another channel, right? แต่ว่าอันนั้นมันจะกระตุกหน่อยนะครับเพราะว่าคอมพิวเตอร์รันอยู่นะครับขออภัยสุรประวินย้ายมาที่อีกช่องแล้วกันนะครับถ้าจะดูนะครับ What else มีคนส่งอะไรมาหรือเปล่าได้ยินเสียงตึ๊ดๆนะครับ Okay, all right. Anything? Of course, I send it. Okay, to you. All right. I don't understand why it's incorrect right here. One thing that is not clear to me is there should be no. Okay, this term should not exist. อันนี้ผิดนะครับต้องไม่มี10 ยกกำลังลบ3 10 กำลัง3ตรงนั้นนะมันพิมพ์เกินครับนั้นand okay, let's compare it by using okay this one Madonna and right. Okay, it's 133.3 13,300, right? And this is the F1, right? F1 is like that and divided by 9, right? And P air, right? P air is gonna be F1, right? F1 divided by the area of P1 piston 1, right? Which is pi times R square, right? Which is 5 E minus 2. Okay, 10 raised to negative 2. And square, and we have here A1, 2, right? It's A1, right? Yeah, let's see what is the value of P air. P air is 18816. Okay, which is incorrect, right? no กดในนั้นผิดนะครับที่ Google นะครับใช้ calculator จริงๆดีกว่านะครับชัวร์กว่านะครับโอเควันเท่าไหร่นะจำไม่ได้ครับถ้าเปิดอีกจอจะดี18816one โอ้ 8816 right 1.8816 oh 6 times 10 raised to negative to 5, right? And pressure is in Pascal, right? It's Pascal. And verify that W input and W output, right? This is not easy, okay? W in and W out, right? So yes, the way to do is like this. If you want to verify, oh my god, ผิดหน้าด้วย okay, if you want to verify, you can start from of course you know that if you move this one, right, it's gonna stay downward, right, and this one go up, and the liquid will fill from one side to another side, and the additional liquid in terms of volume from the right side is gonna be A2 times V2, right, and this A1 times V1, right, but the volume of those sides of both sides should be the same, right, because we assume that the liquid cannot escape from this closed system. So V1, right, is gonna be V2, right, V left and V right, and you know that V1 is delta X, right? We assume that this piston go a little bit down, and that small distance according to the movement is noted by delta X, right? And actually it should be delta Y because it's in the y-axis. Okay, I should not use the delta X. It should be delta Y. Okay, delta Y and delta Y1 too, right? Because this is delta. And here it cannot go up like delta Y1 because this one has larger cross-sectional area. It should go up by the amount of delta Y2. Okay, delta Y2. Okay, V1, the liquid that is lost. Okay, someone has pushed it, and this one is gonna stay on the right side. It's reduced by A which is A1, right, times the difference in the height. Okay, it's delta Y1, right, and V2 on the right side will be A2, right, times delta Y2, and yeah, you just substitute this one to this relation, right? We assume that there is no fluid leak at all in that closed system, so you would have A1 times delta Y1 equals A2 delta Y2, okay, and you would get the relation like this, okay, in the opposite way, A1 divided by A2 equals delta Y2 divided by delta Y1, right? Okay, and that's the first relation, we keep that, okay, and after that you know from the Pascal law that the Pascal law says that the pressure inside at the same height, right? Inside this pump, inside this hydraulic lift would be the same at the same height, okay? So pressure 1 and pressure 2 at the same height, P1 equal P2 could be written as F1 by A1 equals F2 by A2, right? And we're gonna open another page. We keep also this. This is the first equation. This is the second equation. And let's talk about the work, right? The work done by the work on the left hand side and the right hand side. The piston here is gonna move to this one, right? And stupid. Okay. All right. Okay, it moves to the second position, and yeah, this is delta Y1, right? Delta Y1 right here, and you know that W1 on the left side, W1 on the left side will be F, right? There is F1, right? It should be F1 times the distance that the force exerts on, right? Which is right here, delta 1, right? This factor is the h, right? The distance, so it's delta Y1, right? On the right side, we have also the piston, right? And yeah, something like that. And once the time's gone, right? It's gonna move up a little bit like that. Okay, it's gonna move up like that. And here is delta Y2, right? With this distance, and yeah, you would be able to see that W2 is yeah, there will be pressure, and here is F2, right? It just lift this piston up, and it's gonna be F2 times the distance along this force exerting onto that object, right? It's delta Y2, and yeah, you can see that now they want to ask us about proof that W equal Y2 or not, right? Okay, or not, right? We need to have the question mark up on the equality side. รับอาหารไหมโอ้ okay yes W1 we need to observe whether this equality holds true or not, right? In order to do that it means if this one is correct, we're gonna see whether W1 by W2 is equal to number 1 or not, right? I hope you would easily understand, right? This one, you just move W2 to the left hand. We will see whether the ratio W1 by W2 is correct or not, right? Is equal to 1 or not, right? And yeah, let's go ahead with that. Now we start to make the ratio, right? Divide this equation by this one, right? If both are equal to each other, W1 is gonna be W2, and F1 delta Y1, right? Divided by F2 delta Y2, right? Now let's go further down. And you know from the first equation that delta Y2 and delta Y1 has the ratio like this, right? It's A1 by A2, right? So in the opposite way, right? What is the value of delta Y1? Delta Y1 from this equation, from this the equation number 1. It means that oh no, stupid, this one. ขออภัยครับอันนี้ไม่ถูกนะยังไม่ถูกไม่ใช่ไม่ถูกครับมันยังไม่สุดครับโอเค we have to express it in another form which is f1 by f2 equals a1 by a2, right? That's the second equation. Okay, let's consider the first equation. First equation say that delta y1 by delta y2, okay, delta y1 by delta y2 equals a2 by a1, right? Okay, that's equation number 3. No, this is number 3, right? And here is 4, right? Equation number 4. And in equation number 2, they say that f1 by f2 is a1 by a2, right? So substitute 2 and 4 into equation number 3. So พอต้องกี่โมงเนี่ย8:30ต้องจะไปได้9:50ป่ะ9:50เนาะโอเคso yes equation number 2 say f1 by f2 is a1 by a2, right? So from these from equation number 3 we have w1 by w2 equals f1 by f2 is a1 by a2, right? And from this relational delta y1 by delta y2 is this one, right? It's from equation number 4, it's a2 by a1, right? So yeah, you can say that we don't need to we don't have to go into the detail of those a, right? You can see easily a2 up, a2 down, a1 up, a1 down, okay? All of these can cancel each other and you get w1 by w2 equals number 1, right? And therefore we can conclude that w1 work while on the left hand side is going to be the work on the right hand side, because this is the closed system. There is no leak of energy at all. Okay, all right, we finish the first example about Pascal Law. And อันนี้ผมจะลบหน้านี้ยังไงครับจะลบไง Okay, yes, thank you แม่ ใช้ไม่เป็นตั้งนานครับsorry ขอโทษครับมีฮัลโหลครับเรื่องอะไรครับอ๋อเดี๋ยวสักครู่ตอนบ่ายๆได้ไหมครับผมติดธุระอยู่ครับครับ sorry ขอบคุณครับสวัสดีครับ alright what else yes this problem is a good one okay they have three sub questions and yes let me look at that okay and the last one is quite hard, right? Because it talks about the proof, right? You have to know where you have to incorporate, right? You have to include the knowledge about the work too, right? Into that in order to solve that question. Okay, that yes. All right. Yeah. Let's go ahead with the next problem. Right. The previous problem is taken from the book number 1 right here. Okay, you can see it's taken from book number 1, and the second problem is taken from the book number 2. Okay, in let's say suppose the hydraulic lift shown in figure 45. Let's go to figure 45. This one, right? Figure 45 right here. Okay, and has a small cylindrical piston with radius 5 centimeter. Okay, again 5 centimeter on the left hand side, and a larger piston with radius 20 centimeter. Okay, the bigger one. Okay, the previous problem has the larger piston by 15 centimeter, right? But this one is 20 centimeter. And the mass of the car places on the larger piston platform. Okay, the supporter is 1,000 kilogram, right? It's on the same order. That one is 13 Newton. This one is 10,000 Newton, right? Or you can say 9.8. Okay, once you use the G as 9.8. Okay. The two pistons are the same height. Okay, the same height as in this figure. What force must be applied to the small piston to lift the car? Okay, what is F1? Okay, on the left hand side, what is that? And how far must the small piston move down? Okay, to lift the car through the height of 0.1 meter. So what is delta y1? Okay, so that we have delta y2 as 0.1 meter. Okay, that's the question. Those are two questions in this problem, right? So let's open the next page, and we are gonna solve this, right? The first quantity is not difficult, right? Because we just apply the Pascal law, right? Once they say they are at the same height, right? The same level. So F1 by A1 equals F2 by A2. All right. Yes. You can see that this is the result, right? And สำหรับตรงนั้นนะผมดับไฟนิดนึงนะเดี๋ยวมันสะท้อนนะครับ right. Yes. We apply the Pascal Law, right? I think this problem is lighter. It's easier than the previous one, right? The former one. And yes, F1 by A1, right? And we're gonna find F1, right? So we manipulate this equality in terms of F1, right? F1 is gonna be F2, right? F2 times A1 by A2, right? And yeah, it's not difficult. And we know that R1 is 5 centimeter, and R2 is 20 centimeter. All right. Yes, and let's substitute it into that. And F1 will be F2, right? F2, what is that? F2 is the mass of the car, right? Mass of the car times gravitational acceleration on Earth. And you know that this is 1 ton, right? 1,000 kilogram, right? And you have to multiply it by 9.8, right? Acceleration on Earth, you get 9,800 Newton, right? And let's substitute all these three amounts into this expression. F1 is our target, and F2 is 9,800 Newton, and A pi R1, right? R1 is 5 times 10 raised to negative 2 square, right? Divided by pi and 20 times 10 raised to negative 2 and square, right? And yes, you can see that pi can cancel pi, right? And if you go further, it's gonna be 9,800, right? Times this ratio, which is 5 times 10 raised to negative 2 and 20 times 10 raised to negative 2. Okay, this is number 5. And here is square, right? And you can see that 10 unit scale quantity, unit conversion quantity could cancel each other, right? And yes, the next one is 5 and 20, right? This is number 1, this here is number 4. And this one you can use your hand, right? It's 4, 2, right? And 4, right? And 5, right? And 0, right? So it's gonna be 2,450 Newton. Let's check whether it's correct or not. Let's check whether. Oh my God, what happened? Sorry for that. I forget to take the square right here. Oh, I'm stupid. So it's gonna be this one, right? 0 by 16. 4, right? 4 and 4 and 4, right? And 4 here, number 2. Number 4, right? And number 4. 5, 0, right? And again 4, yes, and 4, 1, right? And 2.5, right? It's gonna be something like that. It's 612.5, right? It's correct on the left side. Okay, now it's correct right now. Because I was wrong with our taking the square, and how far must the piston move down, right? The next one is delta y2. Where is that? What is that, right? Delta y2. Delta y2, what is that? ใครพิมพ์อะไรมาอีกเพลินครับเพรันส่งรูปมาว่าเพรันคือณัฐพัฒน์ป่ะสุรปวินโอเคสุรปวินไม่มีปัญหาครับ up to you yes ว่าผมพิมพ์ไปผิดวิดีโอครับโอ้ไม่เป็นไรครับอันไหนก็ได้ครับ no problem สุรปวิน it's no problem at all อันไหนก็ใช้ได้หมดนะครับไม่ซีเรียสครับผมเปิดให้คุณดูทั้งหมดเท่าที่คุณอยากดูนะครับโอเค now let's go ahead with our next target, right? But from the previous question, we know that V1 is A1, right? Times delta Y1, right? And V2 equals A2 delta Y2, right? That's the cross-sectional area. Oh, where's the... Okay, if you move it like this, okay, delta x1 and there's the x2, right? If you move it you move the piston on the left side, it's gonna go down, right? And you have delta x, okay, the final location minus the first location, or the initial location, okay, and delta y1. And on the right side, you start from this level, and the piston just go up, right? And delta y2 is what they request here, which is the 0.1 meter, right? Yeah, delta y2 is 0.1 meter, and assume that this system is perfect, right? There is no leak of hydraulic oil at all. Okay, there is no leak. They have a good seal between the piston and the cylinder and the wall here, okay, on both sides. When there is no leak of hydraulic oil, it means that V1 will be equal to V2, okay? And with this assumption, we would get A1 delta Y1 equals A2 delta Y2, right? And you move, what we want to know is, we would like to know delta Y1, right? We move A1 to the right hand side, okay? Delta Y1 will be equal to A2 by A1, right? And delta Y2 on the right side. Okay, and of course, let's get into the detail. A2 is pi 2 square, right? And A1 is pi R1 square, right? And times delta Y2, right? And yes, of course, you can cancel the pi, and you get delta Y2 in front of that, and here is going to be the ratio of R2 divided by R1 square, right? So let's substitute delta Y2 is 0.1 meter, right? That's what they want to know. And R2 is the bigger radius. They say 20 centimeter, okay, 20 10 to negative 2 divided by the radius on the left side, which is the smaller radius, and 5 centimeter 10 to negative 2, right, and square for that. And yeah, you can see that delta y1, which is the lower distance, okay, the distance along this the lower direction. We should move the piston, right, to get that 0.1 increasing height for the car. and นะเขาก็ยกรถประมาณ10 เซนติเมตรอะไรประมาณนี้เนาะโอเคso it's 0.1 right and here is 4 square, right? Oh no, yeah 5 and 25 4, right? So it's 16 times 0.1 is going to be 1.6 meter, right? Of course, when you work with the smaller piston, you have to reduce more height, right? So that you can get 0.1 increasing height, okay, on the right side. Okay, I hope it's correct. I hope it's correct. Let's check whether 1.6 meter, right? Now let's move to the next topic, okay, which is Buoyant Force. Okay, Buoyant Force. I think yes. According to legend, King Hieron asked this person, Archimedes. Okay, he served for the king. Okay, and in Greek, in the ancient Greek generation, and because the king hired him to work in the palace, and he asked Archimedes, this person, to determine whether, okay, in that generation they don't have so many electronic devices. Okay, they don't have iPhone, they don't have computer, they don't have electronic stuff at all. So the main duty the people in that generation do is solely to consider something precious like diamond, crown, gold, and something like that. Okay, or silver, or something like that. Okay, for decoration. And one of the king costume. Okay, the thing that the king needs to use every day once he go to the to work, right, is the king's crown. And he got the crown from a city or some neighboring area, and people have done the crown and given this crown to him, and he was surprising at that time whether his crown is the true one or not, because they say this is the gold crown. So he asked this guy Archimedes to please verify whether this gold is correct or not, is genuine or not, or it's made of other stuff which is called a gold alloy or not. Okay, so the king has no knowledge to tell himself. So he asked this person, he acts as a mathematician or physicist or something like that at that time. And Archimedes was also surprising, and he was under the pressure. But anyway, he returned from the palace to his house, and he often think about that question. Okay, and he kept that question from the king. Okay, he kept the king's question all the time in his head, and he returns to his home, and at the evening he tried to take a shower, to bath, and there is this piece, right, bathing hub and so on. He leave his clothes out, right? He take his clothes out, and he slowly lay his body down onto the water inside the bathtub and he found that why he feel that his body is not so heavy as in the air, right? And he feels like he lose his weight when once he try to lower his body down into the water. So this is the main idea how the Buoyant force come into physics. Okay, due to this person. Okay, you are unlucky that Archimedes exists in the world. Okay, he should not happens in the world. Okay, he should not exist in the world. But anyway, he is somehow like the founder of this principle, the Buoyant force. Okay, let's get into the detail of the Buoyant force. Buoyancy is the family phenomenon. Okay, in Archimedes' principle. Okay, after he can solve this problem for the king, he created his own principle. It's called Archimedes' principle. He said that an object is completely or partially, when the object is completely or partially immersed in fluid, the fluid exerts an upward force on that object. Okay, because of this experience, okay, he feel that he is lighter, his weight is lighter, and he created that rule, and he concludes that the fluid exerts on upward force on the object, and the upward force is equal to the weight of the fluid that is displaced by the object. Do you get confused? Okay, if you fill this bathtub fully, okay, with the water, and if you lay your body down into that, okay, of course the water will get will exceed the side here, or this four side, and it's gonna get out of this bathtub, right? Because your body has also the volume. Archimedes said that the force that try to keep your body up, it's called upward force, is the product of the volume of that object, of his body. Okay, whether he is partially submerged or fully submerged, the volume of that amount times the mass of the liquid that gets out of this fluid. Okay, you just collect all the water that's out of this bath during your lower your body down onto the bathtub. Okay, collect every piece of water, okay, into a container. Okay, you get the volume of your body that is immersed into the water, and yes, the mass of the mass of your water can be converted to the force, right, by multiplying with 9.8, and that weight is the force that tries to keep your body up. Okay, that's the principle from Archimedes, and yeah, nothing, right? Yeah, everyone has experienced the Archimedes principle every day, but actually we could not realize that. Okay, for example, if you have ever gone to this scenario, มีใครเคยไปนั่งบอลลูนไหมครับ มีใครเคยนั่งบอลลูนไหม หรือว่าเฮลิคอปเตอร์ได้ครับ เฮลิคอปเตอร์วันเด็กอะไรเงี้ยมีไหม Okay, let's take a look at the air balloon and its diagram, right? Of course, there is a fire ignition here, okay, under the air balloon, and this is the actual figure. And if you see the diagram, you can see that the cold air is outside, right, and warm or the hot air is inside, and hot air or warm air has a small density and cold air outside has more density, okay, large density. So this one is lighter, right? It's a lighter fluid. So okay, of course, if you make the fire ignition, it's gonna make the air warm, and it has smaller density, right? And as you know, any fluid, any object that is heavy, that has more density, would stay lower, right? But this one has lower density. He tried to escape to the large density, to any place that has lower density, right? It's like you pour several fluids into the same glass, right? And the lighter, the better that has the lighter density will stay in the upper level, right? And the liquid that is very, very dense, okay, it's gonna stay will stay at the lower position, right? Yes, the density plays a crucial role in the Archimedes principle, and the greater the density of the liquid, the less far the object is submerged. Okay, if you have a fluid which is very dense, and if you lay your body down, okay, they are gonna not leave your body be immersed so much, okay. But if you lay your body down into the fluid that is less dense, okay, they don't have enough strong force to protect you. You can get into that liquid easily and deeper, okay. For example, when you swim in the sea water, it has the density somehow 1030, okay. It's a little bit denser than more dense than the pure water, right? Your body floats higher than in fresh water, density 1000 kilogram per cubic meter. For example, this figure is taken by someone in internet, and I picked it up because I have never been in the Dead Sea, which is in the border between I don't know, it's Israel and Jordan or something like that, okay. And yeah, it's a kind of seawater, but it's very, very dense, okay. The concentration of the salt is very high here in this sea, and it has much it has higher density than normal seawater in the ocean and so on. So when this lady lays down here, she will not get submerged, okay. She just float like this, okay, because the density of this liquid is very, very dense, okay. And I think the time is over, but let's go a little further, because we just lose our time during the computer setup, okay. And one thing that uses one device that uses the Buoyant Force is this one, right? A simple hydrometer, the depth to which the weight scale sinks tells you the density of the fluid, okay. They use also this principle, the Archimedes principle, to build up the meter, which is called hydrometer. It is a meter that measures density, okay. And here, using the hydrometer to measure the density of battery acid and antifreeze, okay. If you have ever looked at the battery in your car, okay, even your father's car, they use the Archimedes principle to tell us whether the battery is in a good state or not, okay, based on the density of that acid fluid, okay. You know that the inside the battery, in the own technology, they use the lead and so on, right? Acid of lead, and when we have enough chemical stuff, the density is more dense than the pure water, and it should have more density. And they use that principle to measure the status of or the condition of the battery. Okay, hydrometers are devices for measuring the density of a fluid. Okay, in this example, and now I think I need to let you have a break, right? So see you on next Wednesday again here in online manner, and the homework for today is about Pascal Law. Okay, find any problem related to Pascal Law or the problem before that. For instance, on Wednesday, what is the problem that we consider on วันพฤหัสเราเรียนกันเรื่องอะไรนะครับผมลืมไปแล้วพฤหัสเรียนกันเรื่องอะไรWhat have we เดี๋ยวนะครับ chapter คนที่เซ็นในคนที่ลงชื่อในซูมแป๊บหนึ่งครับมีประภาวิทย์กับชัยสิทธิ์ครับชัยสิทธิ์มาก่อนเลยครับโอเคOkay, what we have considered on Wednesday is the story about pressure depending on fluid pressure. Okay, fluid pressure in terms of fluid depending on the depth, right? This formula 59, I think that 59 P is P0 plus rho GH. And the second problem that you can choose as the homework is the Pascal Law that uses this expression here, F1 by A1 and F2 by A2. Okay, see you on Wednesday. Bye bye ครับสวัสดีครับ And what else? This one. Oh. Oh, so there is no. What's this one? Này mà. 10. That's it. Okay. So it's yes. We use this one. That one. Two here. For the input. Okay. Why? Because I'm still small. This is the OBS channel. That's quite great. Hey, why doesn't go? Oi. Taoไม่ไปอ่ะ Yeah, should be there. What's the problem?ต่อเลย Yes. Yes. You have that. Okay, good morning everybody. Good morning M605. Are you there? It's time 10:10, right, to 11:50 for M605. All right. Only one is watching in the Zoom to YouTube, right? Yeah, Panathon is the first person for M605, and I hope that everybody is fine and you could hear me well. All right. Okay. The next topic for us in this class will be the first example, right, about Pascal Law, right? I think I have to send you the link, right? โอเคนะครับเดี๋ยวผมส่งลิงก์ให้นะครับสำหรับ yes for those who could not find yeah for some people who want to get into the Zoom meeting. I would often look at your request. I don't understand how we are. This is Zoom to meeting, right? This is another one. Right in this one นะครับถ้าใครจะเข้าที่ซูมนะเดี๋ยวผมลองก็ได้เผื่อว่าคุณมาช้าจากอีกห้องนึงนะครับก็เขาเรียกว่าอะไรเขากำลังทำหนังสืออย่างเป็นทางการกันนะครับว่าคุณจะเรียกว่าอะไรคุณจะให้คุณเรียนออนไลน์ได้โอเคไหมก็ว่ากันไปนะครับanother one is this all right this one, right, and I'm gonna send it to you right now. Okay, 3 channels in the YouTube. You can watch whatever you prefer. Okay, if you are in urgent to get access to the Zoom, okay, just simply make a phone call from the line. Okay, it's no problem. I can understand it because it's in urgent case. Because sometimes when I pay attention to the lecture notes in the good notes on the iPad, okay, I cannot I cannot notice someone would like to enter the Zoom meeting, okay, but for those who are watching the result in the YouTube channel, okay, just simply state it. Okay, if you want to get into Zoom meeting, just let me know by line or by any chat program or make a phone call by line. Okay, let's review the study that we have seen last time. Okay, it's about Pascal Law, right? It's Pascal Law. F by A, right? P1 equals P2, and P is, as we know at the beginning, pressure is the force per perpendicular force per divided by the area, right, that the first exerts on. All right. Yes. Let's continue our story. Here you can see F1 is the force on the left hand side, and A1 is the cross-sectional area on the left side, and F2 is the force, upward force on the right side, which has a bigger piston or bigger cylinder radius. In A2 is the, of course, once we have greater radius, we would have also more area. โอเคก็วันนี้ก็น่าจะสมูทกว่าวันเมื่อวันพุธนะครับเพราะว่ามันไม่ต้องเซตอะไรอันนี้ผมคุ้นเคยอยู่แล้วนะครับถ้าเสียงชัดไม่ชัดดีไม่ดีอย่างไรโปรดบอกนะครับโอเคไหมโปรดบอกผมจะได้จัดแจงทำให้คุณให้ดีที่สุดนะครับไม่รู้ฟังกันจริงหรือเปล่านะครับโอเคalright okay โอเค605 until กฤตภพนะครับที่พิมพ์มาที่นั่นนะครับที่ช่องอื่นยังไม่เห็นมีคนพิมพ์มาเท่าไหร่นะมีธนกรกลิ่นธรรมนะครับที่ซูมนะครับพิมพ์มานะของ605นะครับที่อื่นผมก็ไม่เห็นนะนัทพัฒน์นั่นก็604นะครับโอเคokay anyway let's go ahead with that we have the ratio right คนขอเข้านะครับปันณทัศน์ okay we have the ratio F1 by A1 and F2 by A2 because the pressures are equal to each other, right? We neglect the additional amount of fluid, as I said last time, and yes, we neglect the small difference of piston heights, okay, and that different heights would cause also additional pressure, okay, and we arrive at the next example, right? The first example about Pascal Law. Okay, Pascal Law is a problem about fluid pressure actually. Let's get into the เดี๋ยวผมเสียบหูฟังนี้ด้วยนะที่เครื่องครับก็พิมพ์มาแล้วคือมีกรนะครับอีกคนหนึ่งนะครับแล้วก็ปานทัศน์เข้ามาที่ซูมก็เริ่มพิมพ์มาแล้วนะครับ alright ผมพยายามจะไม่เริ่มเลยนะเพราะว่าเผื่อคนเขามาที่หลังนะครับ alright okay yes in this example they consider okay this example is taken from book number 1 right in a car lift used in a service station compressed air exerts a force on a small piston of a circular cross section having a radius of R1 equal 5 centimeter. Okay, where is the page? Okay. Let's draw the car lift, hydraulic car lift system, right? When you know the principle, you can also build up your own car lift. Okay. The most important thing is the piston. Is the model. Okay. If you know the concept, you can build up your product easily. And it just start from this location, right? Okay. This is the piston, right? These are the pistons, right? This is piston number 1 at the initial state, right? Initial state. And here is also the initial state. Okay, you try to compress มีใครจะเข้าอีกไหมไม่มีเข้านะครับพยายามดูทุกสิ่งทุกอย่างนะครับทั้งลายทั้งอะไรนะครับอันนี้มันห้องผมเซตอุปกรณ์เห็นทุกอย่างครับดังนั้น ค่อนข้างมั่นใจเลยครับไม่เหมือนไปที่โรงเรียนแล้วโอ้โหมันไม่ค่อยมันไม่ใช่มันเป็นไม่อยู่อุปกรณ์ไม่ค่อยครบนะครับทำให้บางทีก็ลืมเซตอันนู้นอันนี้นะครับถ้าตรงนี้เต็มมั่นใจนี่มันจะออกทุกช่องได้สบายๆนะครับโอเค Okay, that's the initial state, and you compress it, right? And you compress it, it's gonna be at the second state, right? It like this. Okay, this one will move downward, right? And the piston will stay at the lower position, like this. Okay, and what is this? Of course, when the fluid has no hole to leak, like so the piston is gonna go up a little bit, right? Yeah, it's gonna go up like this. Okay, and this one is the final state. Okay, the second state. This is the final state, right? In physics, once we have two situations, right, the first state and the second state, we would say something like that, right? Final minus the initial one, right? Okay. Yeah. The basic information they have provided is that R1 on the left side, this is R1, right? The input is 5 centimeter. All right. And here R2 is bigger, right? The bigger one, right? It's 15 centimeter. Okay, the pressure is transmitted by an incompressible liquid. Okay, let's take a look at this word. It's incompressible mean this liquid cannot change its volume. Okay, let's say we have this liquid, right? It's hydraulic oil. Okay, hydraulic oil is incompressible. Okay, it's incompressible liquid. Incompressible mean incompressible means it's equal to volume doesn't change. Okay, doesn't vary with time with any pressure. Okay, and it means from this assumption means the Pascal law holds. Okay, Pascal law holds. Okay, we can use Pascal in this situation. Okay. All right. Let's open the next page. And this one, right? Yes. I hope everything would work perfectly, right? All right. Yeah. The first question they want to know here. Okay. What force must be compressed air exerted on the small piston? Oh, I forgot to mention that they close this section too, right? They close this section. Okay, this one is fixed, closed, and they drill the hole. They drill the hole here. Okay, and there is pump. Okay, this is air pump. Okay, this device just again take the air from environment, okay, from the surrounding area, and take the air and pump the air into this closest space. Okay, there is hole, and they pump the air into this space. Okay, and when the air is high, is more and more. Okay, they have more pressure, and the pressure of the air is gonna push down this piston. Okay, this one is fixed. Okay, This one cannot change. Okay, this is the closing lid of the additional section, right? And this one is connected to fluid, right? When the air here is pumped more and more, right? We have more pressure, and more pressure caused by the air will lower this piston down, and this piston is gonna repel, okay, compress the fluid from the left side to raise this piston up, okay, to make this piston up, and the fluid is gonna stay in this location. Okay, that's the whole story. And they ask us toมีใครเข้าอยู่ไหมครับผมพยายามเดี๋ยวดูเรื่อยๆนะเพราะว่า604เจอแล้วนะครับคือกดขอเข้าซูมแล้วผมไม่ได้ให้เขาเข้านะครับต้องพยายามดูเรื่อยๆครับโอเคPascal Law Horns and we okay they wanna know what is the force we should have here F1 right on the left side, on the smaller side. What the first question is, what is F1? What is that value? And of course we are gonna apply the Pascal law, right? Because this law holds true. And yes, F1 by A1 equals F2 by A2, because P1 and P2 are the same, right? Pascal law said P1 and P2 are the same. Both pressures are the same here in both sides. Okay, and we use the typical formula for pressure. Pressure is force divided by area, right? It's like this. And yes, the force by area is something like that. And we want to find F1, right? So we manipulate this expression to something like this. F1 will be equal to F2 and A1 by A2, right? Something like that. And let's get into the detail. A1. What is the ratio A1 by A2? A1 is, of course, the area of the cylinder which has the circle shape right here. A1 is pi R1 square, right? Pi R1 square, and A2 is pi R2 square, right? And you could easily observe that pi and pi will cancel each other, and you're gonna have R1 divided by R2 square, like that, right? And that's A1 by A2. Now let's substitute this ratio into the formula of F1, right? Yeah, we have F1 equal F2, right? What is F2? The mass here, the second piston is, okay, assume that we have the support, supporting base like that, and you leave a car which has the weight of 13,300, right? It's a car here, and you have a car, right, like that. It's W is 13,300 Newton, okay, like that. And yeah, the weight of this car is going down, right, according to the planet, right, the gravitational acceleration on Earth. Yeah, F2 is 13,000, right? It's 300 Newton, right? In R1 by R2, because now we have found A1 by A2 is only R1 by R2 square, right? So we're gonna write down R1, right? R1, what is that? R1 is the radius on the smaller side, right? So it's gonna be 5 centimeter. Okay, 5 times 10 raised to negative 2, right? And on the right side, it's 15. So it's 15 time 10 raised to negative 2, right? And the power of 2, right? And yeah, we would have right here 13,300, and of course we can cancel each other by the unit conversion term, right? And 5 and 15 is going to be number 1 and 3, and we have 1 by 3 square right here. It's equal to finally 13,300 divided by 9, right? And it's approximately what is that? It's approximately 13,300 divided by 9, right? It's equal to 1477. 1477.7 infinitely, and the unit for this is Newton, right? You get the force on the left hand side in the at the smaller piston, right? มีใครไหมครับไม่มีใครพิมพ์แล้วนะ Okay, yeah, let's move to the second sub question. The second sub question says that what pressure would what air pressure will produce the force that of that magnitude, right? So they want to know what pressure we should have here. The pressure of the air it is inside the air pump. Okay, second one is what is P air. What is P air then in this case? So yeah, we go ahead with that. Of course, we know from the basic formula of the pressure that P is F by A, right? It's on the left side F1, right? And A12, right? This is P air. Okay, F1 is the force that we have got here, 1,477.7 infinitely, and divided by the area. Area is pi r, right, which is 5 centimeter, 10 raised to negative 2 and square, right? It's gonna be something like that. And yes, let's get into the detail of the calculation to this, and we would have the result like here. And yeah, this is the area, right? Pi 5 centimeter square, and P is F1 by P. P is F1 by A1, right? So yeah, like that. And we have to calculate it, right? It's 1.8816. Okay, 1.8816 times 10 to times 10. This is to 5. Okay, 10 to the 5. Where is that? 1.8816. Okay, with the power of 5. And the pressure is, of course, Newton per square meter or Pascal, right? It's Pascal. So something like this. Oh, ขอบคุณครับ. And yeah, we open another page so that we could go ahead with the third sub question. They asked us that show that the work done by the input and the output pistons is the same. Okay, the work done by input and output piston is the same. So of course, when you have a force, okay, you have force like here, and it just go down like this. There is a distance, right? It's called, let's say, delta y1, and here you have delta y2. Okay, delta y1 is the distance along the y-axis by the first piston, and this delta y2 is the distance that this piston move right along the y-axis. Okay, for the second piston here. Okay, delta y2, and yeah, when we have the force and if we multiply it by the distance, we're gonna have the work, right? That's the basic thing in work in physics, right? We don't say work in the office. Okay, we are talking about the work in the sense of physics, which is the product of force and the distance, right, along that force exerting or exerts on, right? Okay, we have to do the life, right? Verify that W1 on the left side equal W2 on the right side. Okay, now how could we do that? Once we see W1 equal W2, it means also that we are talking about the ratio between W1 divided by W2 equals number 1 or not, right? And is that correct? Okay, in under the question, okay, we are not sure yet, but let's see whether this ratio is number 1 or not. If this ratio is number 1, it means the work done by the first piston will be the same as the work done by the second piston. All right, it's not. Is it understandable? All right. Okay. Before we go to that proof, you know that the liquid here in this area, okay, the liquid in this area should be the same as the liquid in this area, okay, because we assume that this car hydraulic lift, okay, this hydraulic car lift is has no leak, okay, there is no hole or the seal of the piston. It works very good, works perfectly. It's impossible that the oil will get escape from this closed system. So when the oil is not cannot be leaked, okay, the volume of the liquid at these two locations would be the same. All right, when the volume are the same, so we would see that volume on the left hand side, that V1 will be equal to V2, right? And if you go to the detail, V1 is A1, right? Oh, A1 times delta Y1, right? Because the volume is the cross-sectional area A1 times delta Y, right? You move it along the y-axis by this amount. So we say that the delta Y1. And for V2, we have also A2 and delta Y2, okay, because you have A2 here, the cross-sectional area of the second piston, and you move it up, right? You're gonna have delta Y, okay, delta Y2, which is right here, okay, delta Y2, okay. Now we could compute the volume at the second side too, right? The bigger piston. And now it's time to substitute this volume into this expression, the volume here also into this expression. We get A1 delta Y1 equal A2, sorry, and delta Y2 here. All right, and let's move something to the same side, right? So we have delta Y1 by delta Y2 equals A2 by A1. Okay, please note that it's in the opposite direction. Okay, number one stay at the numerator here, but number one on the right side we stay at the denominator. Okay, and that's the first equation. Okay, let's keep it. Now we have already that expression, and let's get back to the Pascal formula. Here F1 by A1 is equal to F2 by A2. All right. So we have here Pascal law, right? So we have F1 by A1. F1 by A1 equals F2 by A2, right? So yeah, let's move something together to stay together. Right? We could say that F1 by A1, oh sorry, F2 will be equal to A1 by A2. Okay, and we keep this as the second equation. Okay, now let's get to our destination. We want to see whether W1 and W2 divided by W2 equal 1 or not. Okay, what is W1? W1. Okay, if you take a look at this movement, right? Work is F by A, right? F times A, so F here, F1. And you have also area here, area number 1, right? Sorry, delta X, delta Y1, right, is the distance along the y-axis for this force. So W1 will be the product of force F1 times delta Y1, right? Delta Y1. Okay. And again, the same W2 will be equal to the product of force F2 raising up, right? So it's the product of the force and the distance along the y-axis, which is delta Y2, right? F2 delta Y2. Okay, and according to our target, we want to see whether W1 divided by W2 is equal to number 1 or not. So let's divide these two equations. We're going to have combine these two equations. We have W1 by W2 will be F1 delta Y1 by F2 delta Y2 all right, and W1 by W2 will be F1 by F2 and times delta Y1 by delta Y2, right? And yes, from the let's keep this equation as equation number 3, and we open another page, right? We open another page. we open another page and as substitute equation number 1 and 2 into equation number 3, right? So we would have W1 divided W2, right? F1 by F2 is A1 by A2. So the first term is A1 by A2. And for the second term, delta Y1 by delta Y2, okay, we have got the relationship somehow right here, okay. Here, okay, delta Y1 by delta Y2 is A2 by A1. So what is this? Delta Y1, yes, delta Y1 by delta Y2 will be A2 by A1. So this one is A2 by A1, okay. And you could see that we can cancel each other by this, right? And it's finally only number 1, okay. Here is the complete answer to the first problem today. ขออนุญาตลดแอร์นิดนึงนะครับ Yes, now we go to the next problem to the Pascal law. And what is that? Next problem to the Pascal law is this one, right? Here, okay. Suppose we have, yeah, this one, okay. Suppose we have a hydraulic lift as shown in figure 45. Okay, we have hydraulic lift. In figure 45, okay, and this example is here. Okay, this example is taken from the book number 2, right? In yeah, you have here the lift electric the hydraulic lift, okay, is taken from book number 1 here. We consider the hydraulic lift from book number 2, which are really exactly the same, okay. And suppose the hydraulic lift shown in figure 45 has a small cylindrical piston with radius 5 centimeter. Okay, yeah, let's draw this problem. Let's draw this problem, and yeah, on the left side we are gonna leave it as the smaller piston, right? And yes, again, it's gonna move somehow to the upper location. Yes, right here. And yeah, this is the piston number 1, right? Piston number 2, and it's gonna move down. The distance here is delta Y1, and it is gonna move up in here. Delta is delta Y2, right? And suppose that the small cylinder has radius of 5 centimeter. So radius here is 5 centimeter. And on the right side piston has the radius of 20 centimeter. All right. And the mass, oh, okay, they placed this object to support a car, right? And there is a car which has the wheel here and wheel here. Oh, I'm sorry for that. I cannot draw well the car. And the mass of the car is here M1000 kilogram. Okay, you have 1000 kilogram for the mass of the car here. In let's jump into the first question. Assume that the two pistons stay at the same level and as same as this configuration, right? In piston are at the same height. What force must be applied to the small piston to lift the car? Now we consider the Pascal Law, which is F1. Oh, สีจางไปนะครับ Okay, F1. F1 by what? A1 will be F2 by A2, right? But you know that we want to find F1, right? So you can move it. F1 will be A1 by A2, right? Times F2. And let's consider the ratio of the cross-sectional area. A1 by A2 is equal to pi R1 square, right? Divided by pi R2 square. And yes, of course, we can cancel the pi together from each other. And we have here R1, R2 square, like that. All right. In นะครับเราวิพลนี่จะมาสุดท้ายเสมอครับ Okay, yeah, we have the ratio of A1 and A2 like that, and now let's substitute this ratio into F1 expression. F1 expression will be A1 by A2 is R1 divided by R2 square times F2, right? And yes, R1 is the radius on the smaller size of the piston, which is 5 centimeter, and the bigger piston has the radius of 20 centimeter, right? So this one here we have 5 centimeter. Centimeter is the multiplication by 10 to the negative 2, and R2 is the radius of the bigger piston, which is 20 times 10 less is 2, right? On the same scale, centimeter. And F2 is the base of the car, which is 1000 times the acceleration or the gravitational acceleration of 9.8 in yeah, you can see that I forget number 2. Okay, in this one you cancel each other. In 5 and 20 will be 1 by 4, right? In yes, it's gonna be 9,800, right? In front of that, and the ratio here is 1 by 4 square, right? Which is 16, right? Okay, F1 will be 9,800 divided by 16. Okay, and let's find the result, right? No, it's not approximation at all. It's equally. 4 okay, 4 2 and 4 what is that 4 2 8 right in 18 4 4 right in 25 0 right, and now again 4 here in 24 is gonna be 6 5 1 0 2 8. One, 2, 0.52, right? So it's gonna be 612.5 meter. Oh no, Newton. I'm sick. Okay, that's the Newton. In second quantity they wanna know is the okay, to lift the car we have to exert 612.5 Newton. And how far much the small piston move down to lift the car through a height of 0.1 meter. So what is delta y1? Once we know that delta y2 is 0.1, oh, not millimeter. Okay, 0.1 millimeter, 0.1 meter, and yeah, we start from the fluid that cannot disappear. Okay, this is the uncompressible fluid, and this fluid didn't escape from this device. So V1 will be equal to V2, okay, because there's no leak of hydraulic oil at all. Okay, in just V1 will be, okay, let's say V1 is A1 times delta Y1, right? V2 2, right? A1 delta Y2, right? And now we have again the ratio rate. They want to know V1, delta Y1. Okay, delta Y1 okay, we have here A1 delta Y1 equals A2 delta Y2. Okay, and we want to find delta Y1, right? We move A1 from left side to the right side, we get delta Y1 equals A2 divided by A1 delta Y2. Okay, and A2 by A1 is pi, right? Pi 20 centimeter, 20 centimeter, right? Square to okay, delta Y1 be somehow like that. A2 is 20 centimeter, 10 negative 2, and A1 is pi 5 times 10 negative 2 and square. This one, delta Y1, delta Y2 is the height of the lifting car side, right? So it's this is 9.1. No, 0.1. 0.1 meter, right? So yeah. Okay, let's take a look at this ratio 10 raised to negative 2 and the low one could cancel each other. And 5 and 20 is number 4. And we have a possibility to cancel pi 2, right? So we get 4 square, right? 4 square times 0.1. So 4 square is 16, right? So it's going to be 1.6 meter. Okay, and that's the last answer to this question, the Pascal law. And we are going to move to the next topic. Okay, it's now we have finished the fluid pressure. We arrive at the Buoyant Force. Okay, before we go to the Buoyant Force, let me keep your track record here on several media. Okay, เวลาทอนนะครับGreen Thumb 605. Okay, and who else? Sulapravin. There from oh no, it's M604. Henry Gone is the first person, right? And right here we have many people. Panathon was the first person, and Varin also here. Okay. Okay. All right. Here we arrive at the Buoyant Force, the topic of Buoyant Force. Let's talk about the origin of Buoyant Force. Okay, why or how human has developed the Buoyant Force theory. Okay, in order to understand that, we have to get back to the Greek generation. Okay, ancient Greek generation. At the time, the world is full of several empires, right? Saying now, one of the empire is this one, the king here on, right? Ask this person, and this person is known as Archimedes. Okay, Archimedes is hired by the king because he is expert in physics, in mathematics, and so on, right? He is hired to work in the palace together with the king, and in that generation they don't have electronic devices like iPad, iPhone, television, and so on, right? There is no electronic devices. So the people just pay attention to what they could enjoy at that time. For example, if you are the king, okay, many people are gonna build up the crown, okay, which is a part of your clothes, right? And they would like to give you so that you can help them for some reason, for some purposes, okay. And one day the king has got the crown, right? And it was stated by the person who gave him is that the crown is made of gold, okay, but you are the king, but you cannot believe everyone, right? The detail in he was amazing. Whether he is not sure whether that gold, that crown is made of really gold or not, or it is mixed with other object, other substance, other material. So it's gonna be gold alloy or not. Okay, and he asked Archimedes, okay, who is expert in so many things at that time, and Archimedes, who is the hired by the king. Okay, he has to solve that problem. Okay, because he's the boss, the king would like to know whether the gold is made, the crown is made of pure gold or not. So yeah, in order to do this, Archimedes have got that request from the king, and he tried so many ways to keep this idea. How could we solve? Okay, how could we tell the king? How could I tell the king whether this crown is really gold, made of gold or not? So yeah, what could he do? Okay, he works in the whole day, and one day he returns home. Right, he returns to his house in the evening. He just would like to take a shower, and he take off all his clothes, and at that moment he tries to lay down. Okay, he tried to lay the body down onto the water bath. Okay, the shower bath, and what he feels is that, why I can feel that my body is lighter than the body once I don't live inside the bathtub, not in this shower area. Okay, yeah. What is the reason why he feels that he is lighter once he was laying onto the water inside the bathtub? Yeah, and once he, at this moment, okay, he arrived immediately at the solution. How could we tell the king whether that crown is made of gold or not? Okay, and he arrived at the solution when bathing and noting a partial loss of his weight or lowering himself into the water. Yeah. Okay, so this person is quite clever, right? He can notice everything. Okay, he can try, he can bring the common activity in the daily life situation into the physics law, right? Okay, yeah, you know how he could solve this problem to the king. ทราบไหมครับว่าทำไมอาร์คิมิดีสถึงแก้ปัญหานี้ให้กับพระราชาได้อย่างไรถูกไหมOkay, yeah, buoyancy is a familiar phenomenon, right? หรือภาษาไทยเรียกว่าแรงพยุงแรงอะไรแรงพยุงตัวปะแรงพยุงผมไม่รู้เหมือนกันภาษาไทยเรียกว่าอะไรลืมแล้วครับ Okay, in Archimedes' principle, he said that when an object is completely or partially immersed into fluid, the fluid exerts an upward force on that object. Okay, that's the reason why he feel that he is lighter in water, right, in the shower bath. Yes, he built up his principle, okay, according to the request by the king, and the fluid exerts an upward force on the object, and the upward force is equal to the weight of the fluid that is displaced by the object. Okay, yes, first thing first, there will be force to lift you up. Okay, and that's called Buoyant Force. Okay, and the amount of Buoyant Force is equal to the weight of the liquid or the fluid that gets out of the container. Okay, for example, if you let the water in the same exactly surface of the of this shower bath. Okay, and when you lay your body down into the water, of course the water is gonna escape. Okay, get out of this container, this shower bath. And if you collect all water which gets out of this shower bath, and you collect all that water and lay it into the measurement weight measurement, you get the mass, and if you multiply with the gravitational acceleration on Earth, you already know the value of the buoyant force. Okay, the force that try to keep your body up. Okay, alright, something like that. ขออนุญาตดื่มน้ำสักครู่นะครับ Okay, the buoyant force is the weight of that fluid, okay, that gets out of the container. Okay, the result which is noted by Archimedes. Okay, he's quite clever actually. It's like Newton. Okay, once Newton observed that the apple just fall down out from the tree, so he could form up the principle which is called Newton's law, right? Yeah. Okay, let's see how you type your name here นะครับคอมพิวเตอร์ผมรันงานอยู่นะครับมันก็จะช้าๆนะครับทำให้การแคปเจอร์เพิ่งเห็นนะครับมีประมาณนี้นะ if no one cannot see the result, just let me know. Okay, these are all the results I could observe from many channels. Okay, from a few channels. Okay, everyone actually has experienced the Archimedes principle every day, right, in your daily life. Let's take a look at this one. The air balloon, right? Yeah, maybe you have ever had a chance to travel or to look at this. I'm not sure whether it's popular in Thailand. I hope so. But once in my life, I have ever traveled in Turkey, and they have this kind of thing, right? The air balloon, and under the air balloon, they have the so-called fire ignition, right? It's made of gas, right? And they put the gas and they fry it up, and there is the flame here. The flame is gonna give you the warm air, right, inside this balloon, right? And yeah. On the right side we have the diagram, right? Diagram of the balloon here. Of course, the cold air has large density, and the warm air has small density, right? And the object with smaller density is gonna go up, right? That's the usual thing that happens, right? It's like you know foam, right? The foam, the white one. If you try to leave the foam into try to put it into the water, the foam is gonna get out of the and once you leave the foam is gonna get out of the water, okay, on the surface of the water, because the foam has less density than the water. and this is the same thing here. The warm air, which is the result given by burning the gas here, okay, you get smaller density, and smaller density air will try to escape from the heavy air, right, which is the cold air here, and that's why the hot air is gonna bring you up, and this is the benefit from the fire ignition. Okay, you can travel with the balloon, the air balloon, okay, like this. Okay, that's the first thing that you may experience the Archimedes principle, but it is quite far away from your daily life, right? Because no one is gonna travel to the school or the office by using the air balloon. Okay, the density plays a crucial role in the Archimedes principle. Okay, as you can see here, you have to compare the density of that substance or material. Okay, so you can see, you can judge or you can determine the direction of the force, which is called Buoyant Force. Okay, buoyancy is this direction, right? Yeah, it's the French name. Okay, maybe I didn't let you see you see the correct name, right? Buoyant Force, right? And pronunciation. How to say Buoyant Force? Okay, again, last time we get stuck with what is that? The name of the guy who created the physics principle. Okay. I hope you can hear this one. Buoyant force, okay. Okay, it's called buoyant force. Okay, buoyant force. Yeah, density play a crucial role in Archimedes principle. The greater the density of the liquid, the less far the object is submerged. Okay, and yeah, let's consider one example. When you swim in seawater, and usually the seawater has the density of 1,030 kilogram per cubic meter, and your body flows higher than in fresh water, which has a density of 1,000 kilogram per cubic meter. Okay, the fluid that has more density is gonna bring you up more. Okay, that's the meaning. The less far the object is submerged. It's like this. Okay, in a very salty water, for example, in Dead Sea. Okay, in it's an area between Israel and Jordan. If I can remember properly. Okay, there is a sea which is called Dead Sea. Okay, I don't know the reason why they call Dead Sea, but the density of this seawater is very, very high because it contains so much sodium chloride. Okay, the salt inside here. Okay, and that's why they have more density than the typical seawater. And this lady just lay down onto the Dead Sea, and you can see that she didn't swim at all. But อันนี้ is not magic. Okay, อันนี้ไม่ได้เล่นมายากลนะ อันนี้ของจริงครับ ไม่มีอะไรเห็นน้ำใสๆนะผมพยายามเลือกรูปที่มันน้ำใสๆแล้วคุณจะเห็นว่าเขาไม่มีการพยุงอะไรนะครับ Okay, and you can see that there is no any external support, right? Only the seawater in the Dead Sea, and the seawater here has very high density, so you didn't need to swim at all, okay, and you just lay your body down, and some people just go there to travel and lay down like this and read a book, okay, into the sea, and you get the sunshine. You can enjoy reading, okay, from a book, and or even the newspaper, okay. The people go there, okay. When you float in it, your body displaces less of it, okay. It means you float higher, okay. This is one of the example. You can realize the buoyant force, okay, buoyant force, okay. And with the buoyant force, they also build up the measurement device, okay, which is called hydrometers, okay. Hydrometer is the device to measure the density of something, right, some object or some fluid, right. Here is the hydrometer, and you just they fill it. There is a big area here, okay, and you leave the liquid, like a special liquid, and you have the scale here, okay, and but this device should be calibrated before, okay, from the factory. The depth to which the weight scale sinks tells you the density of the fluid, okay. If your fluid has much higher density than the typical water, this one is gonna go up, okay. But if your fluid has doesn't have so high density or large density, this one is gonna fall down quite a lot, okay. And this is also the way to use hydrometer to measure the density of battery, acid, and antifreeze, okay. Yeah, you know that inside the car there are two components. It's called the first one is battery, right? And in the ancient generation of battery, they use the acid, right, which has also lead, right, PB lead as one of the components. And if your chemical agent inside your battery is in a good condition, okay, the density is not gonna be dense, okay, it's not gonna be large. This device is gonna fall down, okay, and you can use this hydrometer to measure the condition of that chemical object or chemical substance inside your battery, okay. And another component in the car is the radiator, okay. In the radiator, they need to fill in the so-called antifreeze. I forget the name in chemicals word, glycerine or something like that, right? Yes, it's a chemical substance that is used to keep the boiling point of the water to be higher than 100 degrees Celsius, okay. If your fluid in the radiator is pure water, you would have 100 degrees Celsius for the boiling point, but it's not good, right? Because the temperature inside the combustion engine of the car is greater than 100. It's like 600 degrees Celsius. Some of them is used on the scale of 700 degrees Celsius. So 100 degrees Celsius of the water is quite low. So we need to keep the liquid through the radiator be larger than 100 degrees Celsius. Okay, it's like 120 or 30, something like that. So that the flow of that liquid will be good, right? And when the flow of antifreeze inside the radiator and through the engine very well, right? It flows very well. You can get better cooling system for your engine, right? And that's the way. All right. Yeah. This is the hydrometer to measure the antifreeze. Okay, whether it's in the good situation or not. If we don't have so much antifreeze, it means we have only pure water. It's not good for your engine. Okay, to keep it cool. Okay. And I think it's the time is over right now. We need to finish the lecture at the moment. We have passed in this week 2 topics, right? The first one is the pressure depending on the depth, right? Which is the formula of this one, right? 59. We have passed the story about P equal P0 plus rho GH on Wednesday. And today we have seen the application of the Pascal Law, right? The law given by Pascal here. And it is mainly applied to hydraulic lift here, okay? With these 2 topics that you have seen, please do the homework and choose only one topic, okay? Whether you prefer the pressure depending on depth of that liquid or the Pascal law F1 by A1 equal F2 by A2 โอเคการบ้านนะครับทำเรื่องแรงดันที่ขึ้นกับความลึกของเหลวนะครับของ fluid ของไหลหรือคุณเลือก Pascal law ก็ได้นะครับ F1 ส่วน A1 ครับเท่ากับ F2 ส่วน A2 นะครับเลือกมาหัวข้อใดหัวข้อ1เท่านั้นนะครับแล้วก็1ข้อเท่านั้นนะครับเดี๋ยวเปิดใน Google Classroom ครับใครยังไม่ได้เซ็นชื่อนะครับใครยังไม่ได้เช็คชื่ออย่างไรก็ตามนะครับโปรดพิมพ์ชื่อมานะครับใน Zoom มี2คนครับวันนี้คงจบไว้เพียงเท่านี้นะครับsee you on next Wednesday โอเคบ๊ายบายครับสวัสดีครับโอเคthis one too right yes and we stop this one we have to quit the Zoom meeting für alle beenden and this one we have to stop the okay stream and this one right end stream and this one too, right? Finish.